I would first like to introduce Area 4 Industries for everybody who do not know who or what Area 4 Industries is. Basically, Area 4 Industries can be compared with the Volkswagen Group, but not that big. The Volkswagen Group consists of the head, which is Volkswagen, and then they have many different car brands. More or less similar it is with Area 4 Industries. We have 5 different truss brands, which are manufactured all over the world, in Czech Republic, Italy, China, and America, in the USA. But we do not manufacture only trusses. That means aluminum trusses and steel trusses, but as well some other products we have. Under the brand of Mobiltech Lifts, we manufacture wind-up lifts. X-Stage is a range of stage decks platforms. X-Truss is a range of products which can be used to cover trusses to make them looking nicer. And Exit Technology is our Italian brand of electric chain hoists, control systems, and so on. So let's have a look what I will talk about. The first time I held this presentation, only a very few days before happened this incident in Germany, where a live concert was hit in the very beginning, only very short. It was in August last year. It was hit by a thunderstorm, which lasted only 2 minutes, and only 2 times, very short, 2 gusts of wind with 8 Beaufort, which is around maximum 74 kilometers per hour or 46 miles per hour. And the LED screen on the left side of the stage ripped off the truss on which it was hanging from. And it fell into the audience. 10 people got injured, and of course the concert was cancelled. So it is an up-to-date topic. What I will present or show or explain is, I will start with a few pictures about common LED screen applications. How usually in our industry, LED screens are hung from supporting structures. Secondly, I will have a look on the legal basis for design and use of LED screen support structures. Third, there will be some details that should be considered when you hang an LED screen. Then I will compare 2 different support structures taken from manufacturers' catalogs. And finally, I will speak about the behavior of LED screens under wind loads. There's already the first question coming up here. As part of load calculations on the structure, should the LED screen be rigid to the structure? You can be sure this will be answered somehow. It will be discussed within this presentation. And please let me know later if your answer has not been, if your question has not been answered correctly. Yeah, and finally, as a result of the behavior of LED screens, we will have a look which options in different designs this offers. But okay, now let's first have a look on different LED screen applications. I just typed in Google LED screen support structure, and I just grabbed a few pictures that I found, and yeah, the very first one, quite simple, 2 vertical towers, a cross beam on top, probably, or no, most probably, because you can see the electric chain hoist lifted by means of sleeve blocks, and the lateral stability is achieved by external guy wires to the front and the rear side. Another one. This one is not with sleeve blocks, but with rigid corners. And the stability is achieved by stiff truss-made front and rear side outriggers, plus some additional guy wires to reduce the stresses on the T-junctions. And additionally, ballasted by some concrete blocks next to the structure. This is from my opinion, the most simple example. The goalpost sleeve block structure, sleeve blocks on towers, and the lateral stability is achieved by external or outriggers integrated in the bases, plus some diagonal struts stabilizing the towers. This kind of structure is, from my point of view, a nice weather structure. Nice weather structure is for me something that works fine if there's nice weather. As soon as you have wind or considerable wind loads, then there's nothing, nearly nothing, that serves for proper stability. Now we're coming to some bigger structures, in this case the ground support, and the particularity of this structure is that the LED screen is hung on spreader trusses in the center of the ground support. This gives a nicely distributed load on all four towers, but mostly it's not the desired solution, because the front towers may reduce the visibility on the screen. Furthermore, what I can tell to this picture is that the lateral stability, it's not visible from this view how the lateral stability is achieved if the bases have massive and large steel outriggers, or if it is only a very small base plate. It cannot be seen. But what I cannot see as well is any internal guy wire crosses in the walls, which are created by the grid and the towers. So maybe it has a nice and proper stabilization by massive and stiff outriggers. Maybe not, then it's again a nice weather structure. Here, another ground support with the difference to the previous one, that the that the screen is hung on the front truss and not in the center of the grid. And yeah, as well here, some debatable external guy wire assemblies to create the stability. Debatable, I say, because first, the guy wires are made of ratchet straps, which are usually not flame retardant. And furthermore, a ratchet strap has a higher elasticity than a steel guy wire or a steel wire rope, which allows a higher flexibility of the entire structure. So definitely steel wire ropes are preferred compared with ratchet straps. Okay, so far so good. This was just a simple overview. Now let's have a look on the legal basis for design and use. Let's have a look on the European standards. There we have EN 13814 about fairground and amusement park machinery and structures. What the hell has an LED screen support to do with a fairground amusement ride? Nothing. But in the scope of EN 13814 is mentioned as well, besides temporary or permanently installed machinery and structures like roundabouts, swings, boats, Ferris wheels, roller coasters, and so on. But there are mentioned as well booths and stages. So that means that since now this standard covers temporary demountable structures in Europe. At the moment, the European CEN is about to create a new standard which refers exactly solely on the event business industry. I hope that it will be published within the next year, and then we are a bit better covered by European standards. So at the moment, or in the past, our industry has been treated a little bit stepmotherly, but it will be better in future. Having a look over the ocean, from my perspective, as I'm based in Germany, having a look over the ocean to USA, there's the NCE 1.50 about requirements for the structural support of temporary LED video and display systems. So it describes already quite good what we are talking about. Furthermore, in the USA, there's NCE 1.21, temporary structures used for technical production of outdoor entertainment events. So there are quite clearly focused standards available on what we are talking. Of course, there are many other standards as well, but for the moment, let's focus only on these. But there are not only standards available, but as well codes of practice. For example, in UK, a book called Temporary Demountable Structures, it has been published by the Institution of Structural Engineers. Looking on to Germany, SQP 5 about installation and operation of temporary stages and structures. And many more. There are many different other codes of practice available from different countries, but it does not worth to mention them here right now. The basic question is simply, what do all these rules have in common? And what they have in common is that all of them speak about risk assessment or an operational management plan, risk reduction, high wind action plan, Aktionsplan, or however it's called. Basically, these rules have in common that they describe the obligation to carry out a proper risk assessment while assembly, use, and disassembly. And this risk assessment shall be used to create an operational management plan. Okay, it can be called operational management plan, it can be called high wind action plan, it can be called however, but basically important is that this OMP describes what can or should be made, when, how, and by whom in case of expected incidents. And with expected incidents, you can understand strong wind, strong rain, snow, or something similar. This operational management plan should be prepared preferably by 2 or more competent persons or a qualified person. If you want to have a look who or what is competent or qualified, you can have a look in the American NCE 1.2. There's nicely described the difference between qualified and competent. So the OMP sets out the responsibilities for managing the risks. That means it describes if there is a forecast for a thunderstorm, what actions can we do? How will we do this? Who decides to start the measures, and who does these measures, and in which way? So basically, it's not enough only to have this operational management plan. The same important is that people on site needs to be informed about this operational management plan, and all parties, and not only the company who built the structure, but as well the company who assembles the LED screen, if they are not the same. Yeah, okay, but we do not have only the risk assessment and the operational management plan. Finally, or always, what you should take in account is your common sense. And for common sense, I did as well a short Google search, and you can find really thousands of nice pictures that describes common sense. My most favorites have been these three, that of course in a pool you should not breathe underwater. When you are in a building which is burning, you should first exit the building before tweeting about it. And finally, my favorite one, common sense is like deodorant. The people who need it most never use it. So use your deodorant and use your common sense. Now, let's have a look on the third topic. What you should consider when you hang an LED screen. Hopefully, the structure you usually build where you hang your screen has been approved somehow by a structural engineer up front. And if you intend to hang your screen like that, which is the most easy way on the bottom front main cord, you should tell your engineer that you do so. Otherwise, because this kind of load application is not in the center line, not in the center of gravity of the truss. It is eccentric. So the load is applied with a lever arm to the center of gravity, and a force multiplied with a lever arm results in a bending moment. In this case, it is a torquing moment for the truss. If you do not inform your structural engineer that you will hang the screen like this, I usually expect that it's hung properly in the center of gravity. And I would not consider any torquing moments, torquing forces on the truss. And if, for example, the truss has already a utilization close to the limit concerning the shear forces, this additional torquing moment will create an additional load on the diagonals, which might cause a fail of the structure. Okay, so it's always recommended to hang the screen in the center of gravity, because then you do not have the lever arm, and where there's no lever arm, there's no torquing moment. If you always use the same components for hanging the screen, it might look like this. You have the horizontal truss which supports the screen, and it deflects due to the load. And you can see that the blue arrows in the center are shorter than those in the very beginning and the end. And if the round sling has always the same length, it means that not every round sling is loaded with the same load. And this means that the weight of the middle vertical column of LED panels is not introduced in the top span in a vertical direction with the round sling above this vertical column, but the load is transferred to the adjacent panels right and left of that column. And that means that the connection from panel to panel is loaded by shear forces. And usually this connection, what is a simple locking pin or something similar, is not designed for shear forces. It's only, let's say, an erecting help, but it's not structurally designed for vertical loads. So if you hang it like this, you accept the risk of damages on the panel-to-panel connection. That means that if you use components which have always the same length, the truss which is suspending or supporting the LED screen should be sufficiently resistant to bending. On the other hand, if your truss is quite flexible and shows this behavior, then you should use any adjustable suspension. In this case, it has been different electric chain hoists, but here as well again, if you do not control these chain hoists by use of load cells, you cannot guarantee that the panel-to-panel connections right and left are not loaded too much. Another option is to create to use an intermediate truss, which is hung on only 2 hanging points. This picture you have seen already in the very beginning of this webinar. This intermediate truss is supported by 2 chain hoists, and they are not in the very beginning and the end of the black truss. It is somewhere between the third points to quarter points. This way, you can harmonize the deflection between the hanging points with the deflection on the free cantilever, and this reduces the overall deflection and reduces the stresses on the panel-to-panel connection. Okay. I'm happy not to get any more or not any questions on what I've talked about. Otherwise, please let me just know. Let's have a look on the next topic. When you compare informations provided by different manufacturers and compare the load capacities of supporting structures. Here I have 2 different examples. The very first is from the Czech company Milos, the so-called structure LSG3, which you can find in the catalog. The LSG3 is for LED screens for 10 by 6 meters in size. The span is about 11 meters. The overall height is as well round about 11 meters. The horizontal top truss is 1 meter high aluminum truss. The towers are 52 centimeters, square trusses. Having a look in the catalog, you can find the information that the load capacity is 3.2 tons or 7,000 pounds. And with a small star describing that you can have a look in the structural report, how and where exact the load shall be introduced in the structure. So far, so good. Then we can compare this structure with another one from the Italian brand Litec. And the description S11H9 describes the height and the span, which is more or less comparable to the Milos structure. And the towers are as well 52 centimeters square. The main truss is RL105, which is comparable to the Milos RTTH. So speaking about the truss dimensions, the structure dimensions, it's absolutely comparable, but the difference is that here the information about the uniformly distributed load shall be in total 6 tons. Here we had 3.2 tons, and here 6 tons. Why? Where's the difference? You can see here as well, the description of UDL has a small star, which gives a reference to the small print information. And there you can find that the indicative loading data is for use in environments without wind. Of course, when you do not have to consider wind loads, a comparable truss has, of course, way more reserves for vertical loads. So if you compare the manufacturer information, you should have a look or ask for all the details to be able to compare apples with apples and not apples with pears. So far about the theory. Now let's have a look on more interesting practice and the behavior of LED screens under wind loads. Of course, when the screen is assembled and attached to the supporting structure, like in this example, without any connection to the towers, it can swing. How this can look like, you see in this video. It's a nice test setup. What you can see here definitely is that the screen is a quite flexible one, which is intended to be flexible. And it's designed for being flexible. Interesting to see is that they have assembled here different anemometers, 6 in total. And the screen shows the wind speed measured on these 6 anemometers. And the maximum speed is achieved here with 31 meters per second, which is about 100 kilometers per hour. And it's measured here on the bottom right anemometer. And you can see as well that the bottom right corner of the screen is bent most. Important to mention here is that the airplane creates a nearly constant wind speed. But in reality, natural wind is never constant. It has peaks due to gusts of wind. But first, let's have a look. What does it mean when the screen is swinging on a structure? Of course, it can damage the supporting structure. So this can be proven by another video, which was made at the Southside Festival in Germany in 2016. The wind is coming from the direction of view from the guy who was filming. So it looks like the screen is standing still in the air, but it is constantly pressed to the front of stage direction. And sometimes it's smashing again back on the supporting or against the supporting structure. Next morning, it looked like that. Not really what you want to see. At least one column of panels is still working, very good. but everything else you can throw in the bin. But not only the supporting truss on which the screen was hanging from has been crushed. No, only the supporting truss from which it was hanging has been crushed. Thanks God, it has not been crushed the vertical towers of the main stage structure, because this could have caused a collapse of the entire structure. Okay, what else happens when the screen is swinging? It changes the center of gravity of the entire structure. Entire structure means in this case the center of gravity of the supporting structure, including the self-weight of the screen. To visualize this, I have created a model, 2 scaffold towers with a cross truss on top from which the screen is hanging. So far, so good, quite easy, quite simple. Having a look from the side, the center of gravity of the ballast is, in this case, in the center of the structure. The center of gravity of the screen is as well in the center of the structure. When talking about an overturning point on the rear side, when the wind is blowing from right. So what acts against overturning of the whole entire structure is the load of the screen plus the force of the ballast multiplied with half of the structure's depth. The force multiplied with the cantilever is the bending moment or a moment. In this case, the self-weight of the screen and the structure, including the ballast, creates a resisting moment. When the wind is blowing and the screen is swinging, the center of gravity of the ballast and the scaffold structure do not change the position, but the center of gravity of the screen is now exactly vertically over the overturning point, and that means that the self-weight of the screen does not create anymore any resisting moment. That means that the resisting moment is in total smaller. And this can, of course, cause a collapse of the structure. This next video is very short and not really sharp, unfortunately. It was made at the Pukkelpop Festival in Belgium a few years ago. Thanks God it was filmed by someone standing behind the screen and the wind came from his back. So once again, because it is so short, it looks like the right side got a little bit more wind load, so the right tower fell over, it overturned and everything collapsed. So now we have these 2 different points. The next one is that, of course, your screen can be damaged. Another video. The wind is coming from right. The rear wall of the global structure is still closed with a canvas, but the bottom few 2, 3, 4 meters probably is open. So on the lowest few meters, the wind was pressing on the rear side. And it's really swinging a lot. So you've seen that already the right-left panel-to-panel connection is broken. So there you have already the first damages. I will show it again. So you can see the gaps between the columns of panels. Another example, this screen has been attached by these blue ratchet straps, blue, and on the other side the orange ratchet straps to the vertical towers. Nice idea, theoretically, but then the effect is different. The screen is not swinging in total. Now it is swinging only in the center. That means that the panels are bent. 15 years ago, LED panels have had cabinets with a depth of 15-20 centimeters, which created a certain stiffness against bending. Nowadays, the panels are very thin, made of die-casted plastic, mostly. Of course, then they are lightweight, but they do not have a proper stiffness against bending of the panel itself. And when you see this, you might be afraid of your money you have invested in your LED screen. So the solution to provide the swinging of the screen is, of course, to connect the screen to the structure. But then it's the question how this is done. If it is done, like in these two pictures you have already seen, with ratchet straps, it creates a specific behavior. So the bottom picture shows two vertical towers with a screen hanging vertically, and the red line symbolizes a ratchet strap. When you compare, and when the wind is blowing, it does nothing else like this. It is bouncing. And it has the behavior like on a trampoline. On a trampoline, you have all around a lot of springs that these springs have the functionality of a bumper to absorb the horizontal loads which are created by jumping on the trampoline. But here, there's no spring, there's a quite stiff and rigid ratchet strap or whatever is used. And this creates enormous loads pulling the towers together. So if you intend to connect the screen to the towers, it is recommended to do this by horizontal trusses behind the screens, which are connected to the towers. Here, an example, the front view and the rear view. Now, there's this added horizontal truss to which you can connect your screen, and then the wind load is divided or is introduced in the structure not only on the horizontal top truss on which the screen is hanging, but as well half of it, approximately in this case, on the bottom edge to another truss. And then from the horizontal bottom truss, the load is introduced to the towers, but without any additional loads which are pulling the towers together. Then the next question is how many of these horizontal trusses you need to protect your screen from damages. It depends on the strength of your screen. If only 2 or more horizontal trusses are necessary to take the loads to protect the screen from any damages. How the screen can be connected to the truss, it depends on what type of truss you have and what type of screen you have, of course. Most of the screens use these kind of butterfly plates or offers any other way some threads that can be used to connect a coupler or a pipe or whatever. This you have to do by yourself, depending on the combination of truss and screen. and as well on the distance between the screen and the truss. One benefit of using these additional horizontal trusses is, I want to describe right now, when you have this now the same structure as seen before, the wind is blowing on the front side. In this case, the wind load, the complete wind load, is introduced into the structure on the horizontal top truss. So that means in the top height. And here again, the force multiplied with the lever arm, with the distance in relation to the overturning point, creates an overturning moment. What is acting against that is the ballast on the front side and the self weight of the structure, of course, partially, but now let's consider only the ballast, multiplied with the horizontal distance to the overturning point, creates a resisting moment. And as soon your resisting moment is always bigger than your overturning moment, you're safe. What happens when we add this horizontal truss on the bottom edge of the screen? The wind is blowing, the wind is again the same, but only 50% of the wind load is introduced in the structure in the topmost height, and 50% in this example, more or less about in 40% of the height. That means that the total overturning moment is way smaller. On the other hand, that means the depth is the same, and the required resisting moment is smaller because the overturning moment is smaller. That means finally that you need less ballast. So it has its benefits. Now let's have a look on wind loads that needs to be considered. The European standards and as well the American standards describe different setup status, in service and out of service. The condition in service means for a temporary demountable structure that it can be calculated with a reduced wind speed, which is about 40 miles per hour or 64 kilometers per hour, when having a look in the American ANSI code and the Euro code. There's now a question if we are recording this for a review at a later time. Yes, we do. But at the moment, we have not decided yet to publish this, but we didn't decide when, but I guess you can be sure that we will publish this video in future on our homepage, a4i.tv, which is our video channel, where we offer and distribute educational videos, product videos, on-site videos, and so on. Okay, so in service means the structure has a condition which is able to resist a reduced wind speed assumption. Out of service means that the full wind speed is considered in the structural calculation. What the full wind speed is depends, of course, on the venue and the local standards. The difference is, are you on top of a hill or are you in a valley? Is your venue in the middle of the city or is your venue at the seaside? Is your venue in America and USA, or is it in Switzerland? Or is it in Brazil? Of course, these differences needs to be considered in the definition of the maximum wind speed that needs to be considered. In service and out of service, where's the difference? The standards describe that if you calculate with a reduced wind speed in an in-service status, then you must be able to change the setup in a way that either reduces the areas exposed to wind, or that you can strengthen your structure by some measures. But what are these measures? For an LED screen structure, it might be an option to dismantle the screen. Dismantling the screen, for me, I think it's debatable if this is a correct and possible measure. Mostly it takes too long and too much manpower. But there is an option to dismantle a screen. You can see in this video. You can see on the bottom left of your screen, there's someone at a control box, and he's triggering whatever. I don't know if it's a kabuki system or some chain hoist, but it works really fine. Dismantling is very fast, but he does not look like very happy with his solution. So you can decide for yourself if this is the option you want to go. Another option to strengthen the structure is probably to add guy wires and additional ballast. Or another option is as well that you park your screen on the floor, that you bring it down and let it stand on the floor to reduce the height where the horizontal load is applied to the structure to reduce the overturning moment. But then you always have to ask yourself if your operational management plan is realistic. I have another video that describes an improper operational management plan. It is from an incident in Birmingham at the European Soccer Championships. As far as I know, originally it was intended to create a structure like this. Ground support properly stiffened with guy wires in the sides, the rear wall, and the top level. Looks nice. The only thing that I do not like is that the screen can swing. But because of any reason, I don't know, they've decided to change the structure to this design. Perhaps because they did not have enough space. Perhaps they did not have enough money or equipment or whatever. I don't know. And the operational management plan was, in case of strong winds, to stand the screen on the floor, to let it stand on the floor. But then the problem is, they used, of course, some electric chain hoist, but the problem is that when you're using chain hoist, you never know exactly how much of the load is still hanging in the structure and how much of the force or the load is already standing on the ground. So there's a slightly difference between these two pictures. So in this case, the chains have been slightly too slack, and then came a gust of wind. And with this gust of wind, the screen started to fall to the back side like that. And this created a shock load, an impact, a dynamic impact, which started the failure of the structure. So now you can see in this video that in the in-service status, the screen fills the pink frame. Later on, you will see that it's not filling anymore the frame. That means it's standing on the floor. So the British team looked like making a good job. Now you can see that it's no more filling the frame, it's standing on the floor. You can see it's not really a lot of wind. The trees do not move a lot, but it was already enough to let the structure collapse. Another example on a really huge scaffold structure with compared to the overall dimension, the screen has only a quite small surface. But here, when the screen is hanging that high, the disassembly is not an option as well. And even when it's quite small compared to the overall structure's dimension, it is enough to make it collapse. So, not really nice. After having a look on the behavior of the screen and the behavior of the global structure under wind loads, I come to the conclusion that there are a few options how your LED screen structure can be designed. And related with the design, you have to create your operational management plan. The most easy scenario is scenario A. You don't care about any material damages. Okay, if this is your decision to accept that you burn your money, it is okay. From a safety point of view, it is okay as soon you fence off the area around your structure. And as soon you have straight connection to the weather forecast and evacuate the audience early. I guess most people do not choose this option. The next one would be, the screen is intended to be lowered at a certain wind speed level. That means that you bring your screen down on the floor to change your structure from the in service status to out of service. What does it mean? First, if you want to, then you need to avoid damages on the towers. That means you need enough space between the screen and the supporting structure, that it does not smash against the supporting structure. When you lower the screen and stand it on the floor, you accept damages on the bottom row of the LED panels, of course. Therefore, even when it's standing on the floor, you should connect the screen to the structure to avoid the screen tipping over, which can cause the collapse of the whole structure, as we have seen with the example of Birmingham. So the recommendation is that you should add a horizontal truss behind the screen. And in this, now I have to point out, it doesn't matter if it is a horizontal truss or if it is a vertical truss from the top truss to some fixing points on the floor, that doesn't matter. But it should be connected to the screen. And when it's lowered down, then you should keep it hanging, but connected to this horizontal back truss. Keep it hanging to use the self-weight of the screen to increase the resisting moment. But then you have to ask yourself, when you want to lower your screen and it's pressed by a frontal wind against the rearward supporting truss, then it's a question if you can lower it anyhow, or if it's scratching against the along the truss. So here's again the question if this is realistic or not. There came a question, let me see what it is. What hardware do you recommend to attach the horizontal truss to the upright truss? Yeah, that's a good question. The most safe or correct hardware would be to use a swivel coupler, because the swivel coupler has a proper certification for a load and can be defined clearly depending on the load that is introduced. But a swivel coupler mostly have the problem that you never know before installation if and where you can assemble the swivel coupler without any collisions with the bracings of the truss. And even if I would define in a structural report that you need to use two couplers and you cannot find a position somehow, somewhere that allows the assembly of two couplers, then there's a problem, of course. So now we come again to the discrepancy between theory and practice. Even if you use a ratchet strap or whatever hardware you can imagine, any hardware is better than nothing. And it's, yeah, it's sad, but I cannot give the best recommendation what you should use. Yeah. Let's have a look on, no, I don't want to have a look yet. I first have to switch on the lights. It's getting dark already here, and I can't see properly what I'm doing. So the next scenario would be that you leave the screen at regular height and you don't connect the screen to the supporting structure and it can swing. Okay, pros and cons for this solution. Probably the screen might not be damaged because it's not restrained. But we have seen already in some other videos that depending on the strength of the screen, as well the panel-to-panel connections in vertical directions, that means vertical columns of panels together, might break. Nevertheless, when it can swing, as described already in the scenario A, you need to keep enough space to the towers to protect the screen, and more important, to protect the support structure against any horizontal loads smashing against the structure, the towers. So it's a little bit contradictory to the first point. The screen probably might not be damaged, but on the other hand, you might accept damages of your screens. And a disadvantage is definitely that you need quite a lot of ballast, because the resulting wind load is introduced into the structure in the highest position. That means highest position with a maximum wind load creates a huge overturning moment, which on the other hand means that you need a huge resisting moment, which results in high ballast needs. This finally leads us to the scenario D, that you leave the screen in the regular height and you connect the screen several times to the supporting structures. The disadvantage is, of course, you need quite strong trusses and you need quite a lot of ballast. But the advantage is definitely that the screen most probably will not be damaged because it does not swing and it's properly reinforced. And it's definitely the most safe solution. So now we are coming close to the end. And I have to say again that there's always and still definitely the difference between theory and practice, and it's not always possible to connect the screen properly to a structure, and to disassemble the screen is not always possible. I have another video which shows an incident in Ohio in 2012 at the Tattoo Festival, and this structure was hit by a thunderstorm with wind speeds of more than 120 kilometers per hour. So it's 12 Beaufort, which equals to 75 miles per hour. And yeah, how this looked like? No, sorry. Let's start the video. You can see that the screens are already, I don't know if they are standing or still hanging. The entire structure starts to swing. The screens are lifted from the ground. You see already that the first wooden panels starts to fly. The chairs start to fly. Now the guy who's filming is hiding in his truck. You see the whole structure is leaning a lot to the side, and the screen is freely swinging. And even if you would have connected this screen to the supporting stage or whatever it is, I believe you cannot keep it where it was. This is how it looked afterwards. So the right-hand screen is still there. The left one was ripped off, and the American engineer who did an investigation on the damages told me that it flew several hundred meters. So this example clearly shows it's extremely difficult to be prepared for everything, but nevertheless, it's worth to do the best you can to create a safe solution. A few weeks ago, I've been the first time in my life in a drive-in cinema to attend a photo show. It was in my hometown now in June 2020, as Corona started or letting growing drive-in cinemas again. And that was definitely a solution how it should not look like. It was a nice evening. It was presented by someone who had a big adventure with driving his Volkswagen T1 from Istanbul in Turkey to the North Cape in Norway. But the next day, I've been there again to take some more pictures when I could get out of my car. And for me, it looks only like chaos. And it looks like they just started to build and then think the next step. And then the next step, by increasing the strength or whatever ideas they had, I have no clue. The rear view shows a confused assembly of some stage decks. Probably it is for assembling the screen. Probably it should serve for stability. I have no idea. These guy wires, which you can see to the rearward outriggers, yeah, they may help when the wind is blowing from the rear side, but when it's blowing on the front, it does not help at all. And all these ratchets behind the tower in a vertical and a horizontal direction should suspend the screen. But as you have seen already, this creates enormous and huge loads for the trusses, especially already when assembling the ratchets. You cannot control how much force you apply with the ratchet. If you do one click more or less, you already create enormous loads to the truss, even without any wind loads. So the conclusion of this webinar is basically, even if you have a look in the manufacturer's catalog, even if they offer solutions, every LED screen support structure is, from my perspective, it is unique, because it depends on the venue, it depends on the local standards, in which nation you are, it depends on what equipment you have available. Do you have a cherry picker to assemble the structure or disassemble or whatever? Do you have chain hoists available, or do you have only 20 people of manpower available? So you have to decide for yourself. Go to a manufacturer that offers the components, ask what is realistic, or describe your requirements, how huge and how heavy the screen is, and describe what is possible and what not on the venue, how much space you have, and so on. Then we can support you with a proper design that matches on your capabilities. And so you have to make your choice according to your needs, capabilities, and possibilities. Secondly, of course, you need to prepare a proper operational management plan. And having this plan, it's not everything. You must involve all, or inform all involved parties. And finally, I please you to make pressure on the LED screen manufacturers for structural information about the strength of the LED panels, not only for an information how many of them you can hang underneath each other. It's way more important to know, or it's the same important to know how strong the panel-to-panel connection is, how much bending the panel can accept. And this can give a structural engineer a reference or the information how often the screen needs to be supported from the backside. When I started to prepare this presentation, I have contacted 10 different LED screen manufacturers, and only 2 or 3 could provide proper information about the strength of the screen. All of them told me, yes, it is an outdoor screen, but usually outdoor screen for the manufacturers means only that it has an IP rating, that it's waterproof, but not windproof. There's a huge difference. So that's it from my side. If you don't have any more questions, I don't see any more at the moment. If you want to have more educational videos and more information, you can have a look on www.a4i.tv. This is our rigging and trussing television channel, where we spread educational videos, product videos, on-site videos, and whatever you like. If you want to share with us your on-site videos, give us a call, let us know. There's another question. I just have to speak long enough. Can we receive a copy of this presentation for review? As I said already, it is recorded as a video. Sooner or later, we will publish it on A4i TV. If you send me your email address directly to me, norbert.tripp@area4industries.de, you will find it as well on our homepage. I can send you a PDF, a handout, no problem. And as I said, sooner or later, you will see it on a4i.tv. Another question which came in right now is that I didn't discuss the weights needed and the ballasts. Yeah, That's the problem, that it's not easy to answer that. Counting wind loads is extremely complex, and counting the required ballast depends on many different factors. That means the general answer on these general question is always, it depends. It depends on many different factors. Which venue it is, how much wind load you need to consider, how the structure looks like, how the screen is connected to the structure, how huge it is, how heavy the screen is, how high the structure is, how deep it is, how the ballast is connected, and so on, so on. So unfortunately, I know that everybody wants to have simple answers, but there is no simple answer on these questions. The next question right now, when looking at a span of truss, for example 10 meters, what would you consider as UDL beyond quarter point load? Would every 500 millimeter or every 1000 millimeter be regular enough to be considered UDL? Yes. Yeah. This is when you have a look in the manufacturer's catalogs, you find a load chart for uniformly distributed load, center point load, third point load, quarter point load, and not more. That means, as it is, more point loads are not given, because at a certain point, the more single points you have, the behavior or the result of internal loads in the truss is coming more and more equal to a uniformly distributed load. So when we talk about a 10-meter span, every meter a point load is nearly the same, creates nearly the same reaction as UDL. So then it's okay on 10-meter span every meter. If you have a 3-meter span, of course, every meter is not equal to a UDL. Yeah. So this question is answered. This one is answered. I receive already some thanks for this presentation. I thank you for your time. I thanks for your attention. If you liked it, spread the words for Area 4 Industries. Spread the words for the next webinar. It is already in preparation, and it will be about wind loads. I think we will start the next webinar within the next 2, 3, 4 weeks. We will see. So thanks for your attention, and have a nice evening and a nice day. See you soon. Bye-bye.